Hey everybody, this is Adam at Tungsten Amplification. Welcome back to my workshop. We are powering on the Dynaco ST-35 clone project. This meter here is watching the B+. This meter here is watching the voltage coming down to the plate resistors. The amp is currently unloaded. The only tube in there is a GZ34 rectifier. And I'm applying 39 volts of AC power right now. This is the first power on. We're going to slow charge the capacitors today, the filter capacitors. I know there's probably a lot of debate out there on the internet. Over the course of my career, I have experimented with slow charging filter capacitors and with just giving them 120 volts immediately. There is a difference. It's subtle. It has to do with the leading edge transient attack of the note. My preference is to slow charge whenever possible. So with 39 volts AC, we're starting to settle in around 160, maybe 175 volts DC on the B+. We're just going to let it sit here and creep up for a few minutes, and then we will start to dial up the variac slowly. We won't bring it to full power because we don't want to go over the maximum rating of the filter caps with the amp unloaded, but I'll probably bring them up to like 425 or so. I'm going to roll the B+ up to 175 volts. And this is with 45 volts AC. Let's roll this up to 200. That was only bringing it up the AC by 3 volts. We're sitting at 48 volts AC right now. Rolling up the variac again. We're going to shoot for 250. Just very, very small incremental changes upwards. Let it coast through the entire range. Slower is better, but even to do it at this pace is better than giving it full voltage right off the bat. All right, 250. That puts us at 60 volts AC. And looking at the schematic, with the amp loaded, we should be seeing, hang on a second. Sorry for the ham radio intermission. So the first node should be 385 volts. After the choke, we should be approximately 380. And after that 6.8K resistor, we should be at 320. And the plate supply should end up at 320 with a loaded amplifier. Right now, there's really no difference between the third node and the first node with no loading. That doesn't concern me too much right now. I'm glad that there's obviously no shorts, no smoke, no popping. Everybody seems to be doing what they're supposed to be. That always makes me happy. Anything else can be fixed after the fact. So I'm going to pull this lead off, and I'm going to probe the other plate supply. That's also showing the same voltage. I'm curious about my preamp plate supply, so I'm going to probe it up here at the head of the capacitor. And that is also showing the same voltage, which I'm fine with. Let me get the other probe for this so I can poke around a little bit more while we sit here. Okay, so back to the schematic. We should have 370 volts on either side of the output transformer, which will be the blue and brown wires. And then on the ultralinear taps, we should have 375. I didn't mark it on this one, but I did there. Right now, we're going to be much lower than that, but I just want to check and see where we are. Let's see where I can get in. Here's one of the output transformer taps. So that's coming in at 254. Oh, I'm sorry. Coming in at 255 according to this meter, which is close enough. And the ultralinear tap also coming in at 255. I imagine those voltages will settle in to where they're supposed to be when there's tubes in. We can check and see if there is a cathode voltage. Not yet, which would make sense because there's no cathodes attached to it. All right, let's go ahead and roll the AC up a little bit. Shoot for 275, maybe 280. That is at 66 volts AC. If the amp had power tubes in it at this point in time, it would already be conducting, and these voltages would drop because the tubes would be taking up current. When you're working with an unloaded amp like this, it's pretty static. You just dial it in and it's going to sit wherever you leave it. I'm going to go ahead and take this up to 300 volts. And that's with 72 volts AC on the input. It's dialed up to 3 1/4. Generally speaking, I'll do 25 to 50 volt increments every time I touch the variac on the DC side. On the AC side, we're sitting at 77 volts. I'd just like to give that dielectric full time to form in there. I can't explain the science or mathematics behind it, but I can tell you how it feels, at least in a guitar amplifier, and I imagine that translates over to the hi-fi amplifier. I've done it to all the Magnavoxes I burned in after I've recapped them. My thinking too is that when you're building a new amplifier, that if there's a short or any other fault in there that's going to draw excessive current, it's better to happen at a lower voltage than at full voltage. You know, you can catch it before it becomes catastrophic. Dialing up the power again and take it to 350. We're now sitting at 84 volts AC. I know this may not be the most interesting video to just sit and watch a couple meters, but this is the process. I do this every time I build an amplifier, which means I've done this literally hundreds and hundreds of times. Let's go ahead and take it up to 375. I've heard of people stretching this process out over, full 8-hour days. That seems excessive to me. Generally speaking, if I'm really, really milking it, it'll take a full hour. We'll be done here in another 5 minutes at the most. When I put the tubes in and power it up with the tubes for the first time, I will repeat this procedure. Not quite so drawn out, but I'm going to want to bring those tubes up to about half power to verify the orientation of the output transformer wires. Because if we end up with positive feedback, I'd rather have it squeal at half power than full power, because that is loud, very loud. Going to dial up the DC again and the AC. Right now we're sitting at 96 volts AC, and we've got 402 volts on the B plus side. The maximum rating on the filter can capacitor is 450 volts DC, so I'm going to dial it up one more time to 425, and we'll let it sit there. We'll end the video on that. And once I put the tubes in, if we end up really exceeding 385 or 400 volts, that's when I'll start to consider putting a Zener diode string in between the high voltage center tap and ground to drop the B plus a little bit. But we're just playing it by ear. we will see what happens. I'll go ahead and dial this up to 4 1/4. The other consideration as well is that I'm planning to use the 5U4 GB rectifier instead of the GZ34, and that should drop the B plus voltage. In my experience, at least 15 to 30 volts. It just depends. So we're sitting at 102 volts AC and 426/27 volts DC. This is as high as we'll go today. I'm excited though. Everything seems to be working so far. Now if it passes audio the way it's supposed to, I can start to plan out the second amplifier build. I just didn't want to build them side by side until I had actually tested one as a proof of concept to make sure that everything worked. So far so good. Thanks for joining me on this journey. I hope that you like this video. This is, like I said, probably kind of boring for most people, but this is what we do. Next time you see this amplifier, hopefully it will be playing music. Have a good evening.